Thank you, Friday, for the presentation of the first part of this research project. My name is Petro, and here I would like to present the result of our research project. Uh, we use Python version 3, and we use a stat model and other Python model to replicate Hamilton Markov switching model published in 1989. And we use current available real S&P 500 market stock closing price, and as input we use daily return from January 1950 to July 2019. And in our simulation we use some set of parameters like the number of regime is we use 2. We use the order of autoregressive leg polynomial, it was 1, and we use some other parameters like the trend, we use time, uh, and a constant trend. In addition, we use some other parameters like switching exogenous, and it was a Boolean one, and we set it to true. And we also use the last parameters just to set that all regression coefficient will be switching across a region. The next, we got some result, as you can see in this figure. The first one, you can see that we use the Markov switching the Gaussian model, especially uh, as described in the first part of this presentation. It uses a normal distribution. The Markov switching result get from this model is that we get a AIC result equal to minus 114019.219. We got some other result like the probability of moving from region 0 to 0, 1 to 0, for instance. From 0 to 0, the probability of our market regime to stay in that stage is around 83%, and the one from moving from regime 1 to 0 is around 90%. Um, we can also observe in the figure just on the right that during the crisis period of 1987 and 2008, you can observe some high volatility, and for the same data set as S&P 500 market stock closing price, if we fit the same data using the Markov switching student T model, the result here we can see that we get IEC equal to minus 1160.642, and once again here we observe that the probability of regime 1, let's say regime 0, to stay stable is less than the previous model, and the one from moving from regime 1 to 0 is again less, it's around 1%, and so on. Um, we can now making some discussion about this result, and we can say that if we make a graph, what we call smooth probability over the simple period use, we can observe that the first region is usual one, and the second region is also departure from the first one. And usually we can also say that this departure indicate that the SP and fair value the market stock price is going down, although there is some exception. And as said previously, we can also say that during the end of 2008 year, there is a sharp rise on S&P 500 during the regime. And overall, there is a quite high persistence in the state, especially in the first one. And consider that the period is quite long. The one we choose to make our study was around 6 9 years. We can also observe that in the figure of the parameter of the two regime model are almost similar. And when we make our simulation, we use two regime or through the regime, the result was almost similar for both. Um, Looking on the figure on the right, we can see a different AIC and BIC value of the model, the Gaussian and the student distribution. It appears that the AIC prefer the most student distribution range model, whereas the BIC prefer the Gaussian distribution. And referring to the theory that we highlighted in the previous section, we can see here that the AIC parameter for the student distribution model is lower than the one for Gaussian distribution. And we can also notice here that both models include the EM algorithm and the filtering, smoothing, and numerical maximization discussed in the note. Uh, this is not surprising that the Markov switching student T model performed the best, since it exactly matched the data generating process. Also, in the previous section, when we discussed about the model selection, we can also see that the student T Markov switch perform well because it has the lower average AIC than the Markovic switching Gaussian model. Overall, we can say that all two models give reasonably an accurate prediction on the nonlinear part of the model. After this discussion, we can now make some conclusion about our research project. We can say just that the funding of our research favor the non-Gaussian, that is the student Markov model, as the preferred choice for modeling the regime change. And because, as I explained earlier, the AIC and BIC criteria used to select the best model was lower than the one for normal or Gaussian equivalent for the same data used to make our simulation. And we can also say that, as explained in the first part, this finding is very consistent with theoretical proof that student T distribution is more appropriate for modeling financial returns than its Gaussian equivalent because of the allowance of EV tails. As some area of improving our research project in the future, we can just say that there is an area of research that one can look and improve since the generalized hyperbolic distribution is limiting versions for both Gaussian and non-Gaussian distribution. And one can investigate the possibility of designing a Markov switching model that switch both the states and the corresponding distributions to match the change state. And in adoption will be to explore the effect of the regime change on option volatility using the model design in this project. So here is a summary of our result. We discussed a bit about the result, found the and proof that the student T Markovic model performed better than the Gaussian or normal Markovic switching model. And we would like to finish just to thank very much our two instructors, Rita Brata and Mr. Abbott, for their support during this Capstone project. Thank you very much.